Right, now we're going to define a procedure called member. It's a predicate that returns true or false, and it just returns true if the first element, if an item like this 7 is in the list. 1, 3, 1, 2, 4, 7, 9, and that will return true. And then if there was something else like 71, it will look through the list and return false. Alright, so how are we going to do this? So we've got this item here, we'll just call it item, and we got list ls. So when are you going to return false? Let's think about that. You're going to return false when you've searched through the whole list and you've not found the item anywhere. So let's just say member of an empty list, whatever item is, item, and then with the empty list, no matter what the item is, we'll say that is false, because if it's an empty list then item's obviously not inside of it, because nothing's inside of it. Alright, then let's check again. Member. Alright, when are we going to return true? We're going to return true if we find one of these items. So we're basically going to have to go through each one of these items in the list. So first we're going to try a member of this list here, and we'll check the car of the list, which is 1. That doesn't equal 71. Let's put this back to 7. And I'll change that to true. Alright, so we check the car of ls here, which is 1. It doesn't equal 7. So then we'll run member on the CUDA of ls, which is going to be this 2, 4, 7, 9. Okay, then we check the car of ls again. Nope, doesn't work. I mean, it's not equal, so we'll check the CUDA, member of the CUDA of ls again, and that doesn't work again. So we'll do that, and now it does find it, so then it will return true. And it doesn't even need to go on and check 9 because it already knows that 7's in the list. Alright, so let's define this. Define member lambda item ls. Alright, so our base case is let's use a con, since we've basically got 3 cases. Base case is null ls, and what we do there, we return false. Then what if the item equals the other thing? Equal item car of ls. If they're equal, then we return true because we found it in the list. And if they're not equal, then we've got to go down and do the CUDA of the list so that we can check through all the list. So let's do else member CUDA ls. And you've got to remember putting the item back in too, so it searches for the same thing. Alright, let's get rid of that. Run it again. Member member A in the list, do empty list. False. That's good. Let's try member A in the list like A, B, C, D. What? Oh right, I'm sorry. This is like a real scheme function member. See, we defined ours with a question mark. So this is the predicate and this is like the real one. So let's do it again with a question mark. Member, so this is running our function. False. Okay, let's try this again with a question mark on it. Member. Alright, right, so that returns true like we thought it would. Okay, but of course that's easy because A is the first one in the list, so we don't even know, it doesn't even have to do any recursion. So let's change this list up a bit, put like some other things. There we go, and it finds it. Well, let's put this in the little tracer program here. Oh, hold on trace member. Alright, so now we'll just run member on this, and then we can watch and see that it's actually doing its recursion. There we go. So it just goes down the list, keeps running it until it finds it. Alright, that's good. Now let's go down and define another procedure here. Let's see, get to it in my notes. Okay, this is going to be a bit of a tricky procedure. It's called remove first. That takes an element named item and a list named ls, and it returns a list in which the first occurrence of item is removed from ls. Alright, so it'd be like this. Remove we'll say remove first. Like A, B, C. That would be pretty easy. And that'll give you B, C. Okay, now that's not too difficult. But what if A is like in the middle? And what if we're trying to remove B? That has to return A, C. Which is going to be, that's a bit trickier, isn't it? Okay, so let's do the base case here. Base case is when you reach the empty list. That means you just didn't find anything. So remove first of this, whatever that is gonna, whatever this is gonna be, and then empty list will automatically just be the empty list. Well, ls. Yes, the empty list. All right. Now, what if we do the other case is if we find it. So, like, remove first of B, and then a list with like B at the head, and then something else here. A, B, A, C, dot dot dot. Okay. In this case, then, what are we going to do? We're going to have to return the rest of the list. So it'll be the cutter of ls. Because that's ls right there. So the cutter of ls would just be A, C, dot 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 dot. And dot 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 means more elements. It doesn't actually, that's not like the name of an element there. Don't think that would be legal. Alright then, okay. So, and what does it do before it finds it? Like if you got elements before. So let's say you've got like A, C, or A, Z, B, F, T, H. Why not? Alright, so it's going to go through here, it's going to find this A. We've got to have the A on the end of the list. So we know when we get to B, we're going to end up with it's going to return this list here. So what we want to do is cons this part of the list, construct it back into this list here. So we can do that with the cons argument. So let's just okay, let's define it now. Hopefully you'll understand it. Remove first lambda item ls. Okay, so we got three cases, so let's use a cond. Okay, so first case is null ls. Let's just return the empty list. Second case is equal item car ls, and we're going to return the cutter of ls like we said. Third case is else here. If it doesn't equal anything, then we're going to cons item into the remove first of item and the cutter of ls. Right, alright, let's get rid of all this junk and run it. Okay, move first A, A, B, C. That should just give us B and C. That's good. Now let's check something a little bit more complicated. Of Z, H, T, A, B, C. Oh, that did not work. Oh, let's see why. Oh, because we're consing the item back into the remove first. So item was A, so of course that doesn't work. So what does this have to be instead? We want to cons Z, H, and T onto there, which in each instance they would be the car of ls. Alright, so let's copy that so we don't have to type it all out again. Run it, paste it, try it out. There we go, CHTBC. Okay, so that's how we remove an item from the list.